Welcome to the last part on inverse functions. In this video, we're going to look at some algebraic expressions and how we can write them as a composition of both trig functions and inverse trig functions. The first one we have is cosine of sine inverse of x. You've probably never seen this before, so I'm just warning you ahead of time that this is going to look weird at first. Let's say we have a coordinate system, and on that coordinate system, we draw a triangle. But we need to figure out what the relationship between the sine inverse of x is and this triangle that we need to draw. The trick here is we're not going to know what the sides are, except for one. But we can figure out the relationship between the sides. So remember, sine inverse of x is saying that if I have sine of theta equals x, then I can take the sine inverse of both sides and solve for theta. So this is saying that theta is equal to the sine inverse of x. It also means that sine of theta equals x. So notice that I'm doing a little bit of like detective work to figure out what the relationship is with sine of theta. Now remember, x could be x over 1. And remember that sine of theta is opposite over hypotenuse. This is going to be super helpful because now we can write our sine theta as a triangle. There's my angle theta. My opposite side is x, and my hypotenuse is 1. And I don't know the adjacent side, but I can write it as if it's a relationship between the other two sides of the triangle. So let's say I want to find this question mark, this side that we don't know the length of. Well, I know that I have a side, and a hypotenuse of 1, which means I can write this as question mark squared plus x squared equals 1 squared, the Pythagorean theorem. Now all I have to do is solve for this question mark, which seems a little silly, but we'll be able to figure out what that side is. So I'm going to subtract x squared from both sides, and I get the question mark squared equals 1 minus x squared. And then if I take the square root of both sides, I'll get 1 minus x squared under a radical. So what I just found is this side. This side represents a relationship between the hypotenuse and the other side. So it's 1 minus x squared. That's what our question mark, our unknown side, equaled. Sine inverse of sine of theta gives me theta. So this is like saying cosine of theta. There's a lot of stuff going on here. You might need to practice this a few times. Now, cosine of theta is saying I want adjacent over hypotenuse. So I can write cosine of theta with respect to the sides that I know I need. Adjacent is the square root of 1 minus x squared. Hypotenuse is 1. So I can rewrite cosine of theta as equaling the square root of 1 minus x squared. Let's try this again with sine of cotangent inverse of x. The cotangent inverse of x means I will be finding a theta. So sine of theta will be what I'm looking for. If I know that cotan inverse of x is an angle, then I know that the cotangent of theta equals x. Now remember, tangent is opposite over adjacent. So cotangent is equal to adjacent over opposite. And that means that I have x as the adjacent side and 1 as the opposite side. So I'm going to draw my triangle again. This time my triangle will be adjacent is x, opposite is 1, and so I know that the third side, the hypotenuse, is going to be x squared plus 1 squared equals hypotenuse squared. So the square root of x squared plus 1 will equal the hypotenuse. And so I'll just write that along the hypotenuse. That means that I have all 3 of my triangle sides, so I can write the sine of theta as a relationship of opposite over hypotenuse, which is 1 over the square root of x squared plus 1. For now, I'm going to let you leave it this way. Some instructors might make you rationalize, so you might even want to put a note here that says, may need to rationalize for homework. So you'll just have to read the instructions. Now remember, rationalizing would just be taking the square root and multiplying it by a funny looking 1, which is the same as the denominator square root of x squared plus 1 over square root of x squared plus 1. And moving forward, you would have square root of x squared plus 1 all over x squared plus 1. Again, I'm not going to make you do that, but depending on who your instructor is or what your homework instructions say, you may have to know how to do this. So this last question says, a 96-foot tree casts a shadow that is 120 feet long. What is the angle of elevation of the sun? Well, here is our tree. So the sun is shining in on the tree. The tree is 96 feet tall. It has a shadow that's 120 feet long. We need to find the angle of elevation of the sun. This is the angle of elevation here. We have an opposite side and we have an adjacent side. So we can use the tangent function. Tangent of theta equals opposite 96 over adjacent 120. That means that we can impose a tan inverse on both sides to solve for theta. This will give me theta is equal to the tan inverse, or arctan, of 96 over 120. If we do this in degrees, it will be a little easier to calculate. Grab your calculator, turn it on, make sure that you are in degrees, so check your mode, go to degrees, second quit, now do tan inverse, or arctan, of 96 divided by 120. And you get 38.659. We're just going to go ahead and round that up to 39 degrees. This is a beautiful example of how you can solve for the angle now using an inverse trig function.